excited to kick off our panel, as you can tell, looking beyond the AI horizon, where we're going to talk about maybe AGI and how we can get there. I'm Kiranuthi, the head of AI and data at techUK, which covers everything AI policy and innovation development and deployment within our association. And I will let you guys do your intros rather than butcher it myself. But to just do a tiny set scene, this is not going to be your classic conversation or panel on AGI. We're not going to really be talking about the buzzwords or the hype. I really want us to focus in on the genuine technical questions that are going to affect the next generation of artificial intelligence. So the big topic question we're posing today: what foundational compute infrastructure will we need to move beyond today's artificial intelligence? And when it comes to AGI and next-gen artificial intelligence, is the UK positioned in a good place to be able to build that? In that sort of sense, I'm hoping we cut through the noise and have a fun discussion. So we're not going to debate when it'll arrive, as much as I think we could probably fill a whole day with that. Instead, we're going to examine concrete technologies. So we've got an amazing set of companies and academics in the room to talk about novel computing architecture, energy-efficient hardware, all the really geeky stuff on what it's going to take to build the groundwork for advanced AI. Rather than, as I mentioned, butcher your introductions myself, I kind of want to set this off with, can you tell us who you are, where you're coming from, and kind of give us your grounding definition for the conversation. What are we talking about when it comes to advanced AI, next-gen AI, AGI, from your perspective? I'll go down the line, and I promise this will be the last time I go down the line. We'll also end the conversation with, I'm hoping, 10 minutes of Q&A, just to liven things up a little bit, and we'll go from there. Sound good?
Perfect.
Sweet.
So I'm Rahul Tyagi, CEO and founder of Sakai. We are a secure semiconductor organization that build devices that protect you against 70% of all known cyber attacks. We integrate that with post-quantum cryptography to encrypt communication, but we also have done significant research in the field of neuromorphic hardware, all the way through to quantum systems, using machine learning on quantum systems, and more importantly, using quantum-inspired techniques for machine learning as well. I think the AGI topic is obviously a very broad one that gets butchered a lot, so I won't try in defining it properly. But we try and stay quite clearly away from the word AGI, because in my book, an AGI is something that's properly physical and is basically a robot that can do everything from doing all of my dishes, doing my washing, all the way through to solving the biggest challenges in physics and maths. Unfortunately, that's probably very, very far away. So to keep it in kind of real terms, our view is we've got, for the next 2-3 years, different AI architectures and different AI paradigms. We're looking at how do you go about integrating that securely in hardware and how to go about delivering that in hardware. And this is everything from language models through to multimodal models, even including things like energy-based models, which is what we're starting to see now more recently.
Amazing. Abdul?
Okay, thank you very much. I'm Abdul Sadka. I'm a professor of AI and multimodal data technologies. I come from Aston University, where I lead the interdisciplinary research institute called the Sir Peter Rigby Digital Futures Institute. With regards to the question on AGI, I mean, it's an emerging form of AI which is intended to replicate, if not surpass, human cognitive intelligence in such a way that it can interpret, analyze, decide, think, understand, learn from some domains, and apply this knowledge to multiple domains that people face up with in their daily life, with such high level of emotional and cognitive intelligence. That's it in a nutshell.
Last but not least, Ed.
I'm Ed. I'm head of strategy and sovereign partnerships at Fractile, and also feeling slightly underdressed. So Fractile is a company which is building next-gen compute systems, and I think whether or not we look all the way to AGI, the one thing that's very clear at the moment, and this has been the case for a few years, is that as AI becomes more performant, essentially this is based on running longer context tasks, essentially tasks that involve processing more information. And the fundamentals of making that possible, and the bet that companies like OpenAI and Anthropic have made since around 2016, is that compute becomes more powerful over time on a log scale, and that they can follow that log scale in enabling that performance. So I think that the key question, irrespective of whether we get to AGI or whether we just follow the trend towards better, smarter, faster models, is the same answer, is how much is the UK going to be a player in the compute stack? And the reason I work at Fractal is because I think we can be.
Awesome. Okay, we've covered everything from staying away from the concept of AGI to what it actually means. But two of you have mentioned advancements being necessary for what I would call increasingly capable AI systems. What exactly are we talking about? I'll go to you, Ed, and then I'll go to you, to Rahul, when it comes to advancing computational infrastructure for this moving into our further future of maybe hitting the Jetsons.
Sure. So I think if you look at what's been possible in the last few years of computing, and I imagine everyone's familiar roughly with the principle of Moore's law, that over time we can concentrate more transistors on the same amount of silicon, and that means faster, smarter, more energy efficient processing because you're using less energy per bit, and those bits are closer to each other. We've scaled that 1 million times in the last 30 years, and in the accompanying time, we've scaled the memory access 40 times. So the bottleneck to making this more performant at the moment is on the memory side. The machine, like a GPU right now, is phenomenally powerful in how much calculations it can perform. And next to it, you have a big thing called high bandwidth memory, which is it's giving away the weakness in a sense. It actually has very good capacity and very bad bandwidth, because the bandwidth is it's beachfronted onto the GPU. And I think that the thing that will make that more, the potential right now is all in the memory access. It's something that, lead analysts in the sector like semi-analysis, Dylan Patel, call the memory wall. That unless we smash through this barrier that separates the information we try to process from the machine that actually processes it, we're not going to be able to keep this performance scale going. But at the same time, if we do smash through that, then a whole new world opens up.
You guys do quite a lot of research on not necessarily the memory wall, but where other computing architectures fit into this. I'm going to pose the same question, but with slight adjustments given that. How is it focusing out at techUK?
Yeah, so I think from our perspective, we're kind of in a nice area of new computing paradigms. So yes, we've had kind of the traditional semiconductor kind of resurgence happening right now. We've also had the innovations happening in photonics. So there's been different approaches from general photonic accelerators all the way through to photonicizing machines. We've seen quantum computing paradigms also accelerating with measurement-based approaches, gate-based approaches, all the way through to annealers, which has created this really interesting environment where we don't really know where it could go. So yes, we do have the existing kind of transformer-based models that we have today, but what we're now enabling in the next 2 to 3 to 4 years is innovation in other computing architectures and paradigms that could enable models that were previously impossible for us to run. So the areas of research that we focused on is, yes, we've done some research in spiking neural networks. Unfortunately, there's practically no hardware that you can actually run something and train something on today. The second big area that we've researched is in gate-based quantum systems. Although they're very interesting, unfortunately, they also have a number of different engineering problems. I probably don't need to state that in this room, but we're probably going to see proper QML algorithms still being 5 to 10 years away, and a lot of research needed in that domain. The areas that we see the biggest kind of capability in is really the need to integrate architectures like inference accelerators directly with CPU processors. And the reason for that is we're now starting to see the need for, as Ed was saying, longer reasoning, longer chain of thought, but also the direct integration of that with software applications for agentic style systems. So if you want to do formal verification of inputs and outputs, you need to have that really tightly coupled with your existing software. And if you don't have that, you're going to have a latency problem between the inference and your traditional software. So that's the kind of thing that we're starting to see now as being the big requirement. And NVIDIA and AMD have started going down that route, NVIDIA namely with the Grace architecture being kind of the predominant thing that they've been driving towards.
Okay, so memory walls, latency issues to kind of generalize in that sort of space, particularly like inference accelerators into CPUs. Abdul, I want to bring you in to kind of narrow into the limits of today's architecture. Are those the only two things capping near-term performance for advanced AI? Are there other bits that we need to be adding to this conversation?
Yeah, sure there are. Well, first of all, it's not just about the intelligent high-performance hardware that is really missing. It's really what comes on top of it. It's the software tools as well as the high-performance specialist data processing algorithms, which are required to extract knowledge from large volumes of data, which is continuously changing, and apply this acquired knowledge across multiple domains to enable decision-making, interpretation, analysis, etc. So the limitation today is not purely because we haven't got enough hardware that could manipulate, handle, and analyze large volumes of data, which are continuously changing. But it's really the lack of research and innovation maturity in this area, algorithmic prematurity, which is to bring AI to the level of human intelligence, cognitive intelligence, so that an AI model can think, perform, and decide in the same way, if not better, than human intelligence. So this is where I think the bottleneck is.
Rahul, do you want to jump in there, considering you guys kind of cross both of these spaces of software and hardware?
Yeah, I mean, I would say I 100% agree. There does need to be a lot of research more into the different software architectures that are being explored. There's still kind of this focus on the pre-existing methods that are being used and deployed by the biggest players out there. But when you read all of the papers being published on Archive, you see that there's actually a lot more out there that would be really interesting, maybe if it just got the scale and attention that some of those other players do have. Notably, a lot of the verification stuff we are finding really interesting. The EBMs, those sorts of models they're also very interesting for us. But to see which one's actually going to win and scale is really difficult to see at this stage.
Win and scale is a phrase I actually really enjoy, and I think we've talked a lot about scale in this sort of conversation, Ed, before. Do you want to add into that sort of part of the conversation?
Yeah, I think it's a really interesting point around, like, especially in the software layer. That is, I think, something that's held back some of the previous rival efforts to NVIDIA, that they've built very, very interesting and powerful pieces of novel hardware, but then they don't have a software stack that can feed that hardware enough information to actually outperform CUDA kernel. So I think that really, it all comes together, and you have to have, and I think this is where the Fractal wants to be, how the UK leads the world in AGI, is exactly you win and scale by having a hardware-software integration that the entire thing sings together. And then you can also, essentially like NVIDIA have with companies like Together AI, cracked engineers that rewrite the CUDA kernels because they can. But you need to have, at the very least, a very, very strong software stack already that really allows an ecosystem to be built on top of that. And NVIDIA have done an amazing job of that. It's really, really impressive and interesting, some of the stuff that they've done, say, with, for example, the GTC now is this amazing psychedelic theatre show in which Jensen tells you how the new world would be possible. But at the start of it, what was brilliant about GTC was it was a conference in which people who were using parallel computing for different things all got together and told each other what they were doing and how exciting it was. And that builds out, I think, how you win and scale in that sort of situation is you create an ecosystem, you create a market, and that requires you to absolutely have like a really well integrated hardware and software stack, and then also, get the developers involved.
I really like that idea of integration of the hardware and software stack. You guys mentioned it almost as like a feedback loop of strong hardware leads to strong novel software leads to strong novel hardware. Abdul, I kind of want to jump into the conversation around, well, for lack of a better word in my head, compute, and the emerging paradigms that we're seeing in that feedback loop for the UK's approach to compute. We've seen quite a lot from the UK-US tech partnership deal, AI opportunities planned back in January, AI growth zone announcements on compute being a really strong path forward. What emerging in that sort of space should we also be thinking about outside of today's AI?
It's going to be a multitude of existing and new technologies which is going to be incorporated in the new compute paradigm infrastructure. We talked about neuromorphic, we talk about photonic-based compute paradigm, we talk about quantum compute platforms, we talk about edge compute, but it's a combination of those so that the resulting infrastructure would be scalable depending on the level of complexity of the AGI task at hand and the volumes of data that the AGI model will have to deal with. So you can program the load of your processing load based on the task at hand. So it becomes scalable. You can either upscale or downscale the compute requirements or power required in conjunction with the task at hand and the volumes of data that the model will have to extract knowledge from. So I think it's a combination of these things. We wouldn't see just H100s or G100s GPU-capable machines deployed out there to generate a large language model with billions of static parameters. I think it's a multitude of CPUs, GPUs, TPUs, and neural processing units as well working together in an adaptive way, in a scalable manner, depending on the task at hand. I think this is key, scalability.
Scalability, and I'd almost argue it's diversification
Yes.
of what you're playing with. It's not necessarily your classics. Rahul, you guys have experimented throughout this. Where are you seeing the strengths and gaps to add to this sort of idea of diversifying for advanced artificial intelligence or advanced intelligence if you're thinking on a neural crowd? Where are the strengths and gaps? Where are you guys seeing the state of play?
So I think we'd probably take it looking more geographically. So I think in the UK, we have incredible talent when it comes to AI research. The thing that we probably are missing is access to a lot of capital that can be invested in the novel areas that we're researching. So there's some fantastic work going on at Oxford around neuromorphics, for example. That's been heavily underfunded, I would say, even though it shows a lot of promise. There's areas in the quantum software domain. I think quantum software is an area that is heavily underinvested as well. We've invested a lot in hardware and trying to build quantum systems that work, which is, again, like I said earlier, a bit away at the moment. But the software, we've really not invested enough capital and got the right resources working on it. If our brightest brains are being attracted by the financial services industry, going into that industry, how can we then build something that's really competitive in the quantum algorithm domain and something that may be potentially able to surpass existing machine learning models? In-house, we already have a transform model that runs quadratically faster on a quantum computer compared to any classical algorithm. The problem is no quantum computer exists for us to scale that. We'd rather get it to exponential, but we're still quite far away from making those optimizations. So that's where we think kind of the biggest investment really needs to go down.
Okay. I imagine it's slightly different from a Fractal point of view, but also along the same lines of investment and talent on where the UK strengths and gaps are for emerging compute. Ed, what are you guys seeing?
Yeah, I think the Fractal, from our perspective, the UK has a very, very good bench of fundamental semiconductor talent. There's people who've grown companies like ARM or other ones in the past like GraphCore and so on with amazing engineering leadership and vision. And I'm happy to say that many of those people have now invested in us. So that's helped us sort of deepen our own bench of talent. And I think there's a core of people who've been working in the UK on this sort of stuff since the 70s, since companies like Inmos and Acorn first started up. And that's kept a sort of core capability. But at the same time, we need to grow that. And that requires us to be all in on growing our current generation of companies, because there's been a bit of a, it's not that we haven't still got it, but we haven't grown it as much as we could have in the last 20 years. So we have people who've been all the way through the stack. So people there are people who are working in Fractal. So for example, our senior vice president for hardware, Pete Hughes, he's worked in the semiconductor industry at leading edge since the late 80s. And he's grown and exited 3 startups for hundreds of millions each and worked at the same time as, senior in Broadcom and NVIDIA. People like that are there. And then we have really great grads. But at the same time, we need to be hiring more grads. We need to be training more grads. And the same, I think, would be the case for the capital markets issue is essentially, we have enough money that you can get seed and you can get going. If you want to raise a $150 million round, you're probably going to need to have at least some money from the US. And that's something which is currently the case, but the more we grow from now, the better that is. And the more amazing angels you have in the ecosystem who exited 10 years ago and so on. I think that's something you really see when you go to Dubai. You'll meet people who run funds or are just very prolific angels, and you'll be like, oh, how did you get your money? And I'll be like, oh, I was like employee number 12 in Paggle. And you haven't even heard of Paggle, but apparently they made a dongle that they sold to Google in 2002 or whatever. And that's just, it's the law of compound interest on just a ridiculously high power law. That the more people you have angel investing in companies that then successfully exit and then they angel invest in companies, that's how I think we grow the system from where we are.
Okay. We've talked quite a lot about scaling and diversification in that sort of regard. And frankly, I think you guys have answered a bit of what's going to be my next question. And it's partially because it's the one that interests me the most. How do we focus on that scale and diversification and investment challenge to compete on the next gen AI into AGI? Is there a path forward for academics, startups, companies that have been around a long time in the UK to compete on that moving forward? I'll go to you, Abdul, and then I'll flip that way.
I think I touched back on the algorithmic prematurity. What is currently in existence is a set or a suite of algorithms which are capable of extracting features from natural language, semantics, or audiovisual features from multimedia assets, audiovisual assets. In order to generate, talking about generative AI, to generate a large language model which has billion of static parameters, once they have been defined, those parameters are frozen. So you can't go back to manipulate or change those parameters unless you do a pre-training from scratch, again, to either add or modify those parameters. That's not good enough for AGI. You need a model which is dynamic, which changes every time it's exposed to new assets of information, so that it can adapt to multiple domains, because that's the key purpose of AGI, is to transfer knowledge and apply knowledge across multiple domains once this knowledge is extracted from one domain. So static models can't handle it, can't manipulate such a knowledge transfer. You need dynamic models, but you then risk the what is normally referred to as data poisoning problem. To open up the model for end users to manipulate and change those parameters means that they could import data which could poison the large language model, and you need to secure and safeguard the model from being poisoned as such. So you run into a dilemma here. You want your model to be dynamic, but you don't want the model to be exposed to external interferences. So this is, I think, the key dilemma that the research and innovation activities will have to grapple with. Another thing is, of course, on the compute side of things, it's the lack of an infrastructure which is diversified enough, which is multi-technology, scalable enough to deal with the compute requirements that training a model and extracting knowledge with the same level of human cognitive capabilities require. The lack of such an infrastructure deployed with all the tools, overlying tools and facilities deployed, makes it quite difficult for us researchers to innovate in this domain. So I think these are the two stringent bottlenecks the way it's at the moment.
Okay. Figuring out how to get more mature knowledge transfer, but also figuring out where the multi-tech system is that can get us to a place, because it's probably not just a singular mode moving forward. Is that correct to say?
Absolutely.
Okay. Sorry, I'm saying okay. Okay is my thinking word. So if you hear it more and more, it's because I'm processing very slowly. Rahul, I kind of want to jump into it for you guys on what scale diversification and investment means for looking forward. I know you guys have talked about quantum before, you've talked about neuromorphic. How are you looking at the scale challenge and investment challenge moving out of classical AI, but how are you looking at it when you're just thinking about the next generation of technologies you guys will be working on next?
Yeah, so we have to do a lot of cost-benefit analysis as to whether or not something is worthwhile us researching for a year's worth of time. So even in our quantum AI research, we spent about 2 years researching that domain to come to the conclusion that yes, this is exciting, but maybe exciting in 7 years' time when we can actually run it. So it was always this kind of balance between the two. Looking at the scalability, it is quite a big challenge. I think one of the things that's really good that the UK government has done is provide access to GPU resources for academia. And we've been looking to work with a different set of academic institutions to run prototypes of things that would be infeasible for us to run, because we'd need a couple of $10 million to run it, and work with them on running those sorts of systems. I think the thing that would be really useful for us, not necessarily just from a scale perspective, but actually more from the investment perspective, is being able to tightly couple what we're researching with academia. So the number of times we are scanning archive and finding a professor who's working on something really interesting, we contact that professor and they're like, yes, I would love to collaborate in any way that we possibly can. That's great, but there's no kind of means for us to do that today. Like, there's no kind of channel that we can go down. Yes, there are Innovate UK grants, but there's nothing that we can go down saying, look, we've got a leading academic in this research field. We have an idea that they're really confident will work. We would like to test it and scale it. There's nowhere for us to go today. So I think plugging that gap for us to be able to do that would be really useful. And then, of course, trying to open source all of that code would be ideal to then foster greater collaboration across the entire academic environment.
Okay. It's almost sounding like balancing the experimentation and like the academic research side of it with the commercial viability side of the equation is increasingly important when it comes to scaling for like the next generation of AI. Ed, I know we talk quite a lot about this ourselves, and you and I have definitely calendared our days worth of chats on experimentation and commercial viability, but you guys have a very different business model at Fractal. Are there elements we're missing from what Abdullah and Rahul are saying about what we need for scale and investment to compete as the UK moving forward?
I wouldn't say missing. I think possibly the next phase is where ARIA steps in really usefully. Like when you say, and I don't know whether ARIA might be potentially useful for that problem that you just described, Raoul, where essentially you can bid as one organization for ARIA, or you could bid as a consortium. But in either way, you sort of say, ARIA have defined a set of big problems that they think we need to solve at the moment, like scaling up compute and drug discovery and so on. And what essentially they allow you to do is you go to them and you say, we've got an amazing team and we think we've got a way to solve this problem. And they give you around £5 million to have a go. And they're pretty open-minded about what you do as long as you have the chops to give it a good go. And if you don't solve the problem, then you can try a different way. You can, and it's a very responsive and it's a sort of genuinely pro-innovation funding structure in which the point is the problem solving, not the original pitch. I think that's quite different to traditional innovate funding, which is often quite programmatic. They'll sort of say, there's a funding pot here for somebody to do this exact thing that we've already identified that people are going to be doing. Whereas at ARIA are more like, how do you solve this problem? And then people are going to come in, and some of the pitches will be crazy. But some of them will be crazy and also work. So that's, I think, it's a really really great thing that since ARIA was set up, the Matt Clifford reports on AI has also doubled down on this of saying, we need to make bigger bets on a set of technological approaches which are very aggressively scalable and also then can be commercialized, potentially. And they don't all have to be commercialized. You can look at something, let's say, OpenBind, the sovereign AI unit have done, which is not so commercializable, but is more just focusing on improving the ecosystem. Or you can look at something like ARIA sponsoring us with £5 million to get to where we are now. Essentially, we've essentially moved through the valley of death of the early to scaling company, and now we have a product that we will be making next year. And that's essentially, I think, where the innovation funding gap has been really effectively solved, and I think we should do more of that. We should get more big pots of public money and sort of say, just give them to companies that are doing ambitious things.
Aggressively scalable, and then I'm sure there's a quote in there for crazy equaling genius that I'm going to misquote Einstein if I try to do. I kind of want to jump in on, there's a lot of opportunities the three of you guys have just mentioned, and we've got about 10 minutes before I'm going to hard pivot us to Q&A so we can talk probably even more about the AGI of this conversation. I'm going to pose it down the line of, there's a lot of opportunities if we bridge the risks between academics and we bridge the conversations across industry, academia, government, and everyone else. Where can we credibly lead? So if this conversation is happening internationally, it's not just happening in the United Kingdom. There's some really big capital pools and places with accents like mine. Where is the UK going to go next? And are we in the sort of place of catching up already? Or are there places we need to start catching up really quickly before we get behind? I'll go to you, Ed, and then I'll actually reverse a line down.
Sure. So I think that when you look at the AGI paradigm, it doesn't meaningfully distinguish itself from the AI paradigm. So I think we can just talk about what we already have. You have chips, you have inputs that goes into those chips, and then you have people build data centers in places where energy and water are relatively plentiful, and then those are run by a cloud service provider or sometimes an inference specialist provider, and then that is used by a model company to then either serve the model directly to consumers or possibly interface through an application like Cursor. Mm-hmm. Those are the fundamentals of the stack. And there are some things in there like making chips or making applications which require you to have very good talent, very good business environment, and decent pool of capital. And there are other things in there like operating large data centers which require you to have plentiful energy and water. I think we should be realistic about where the biggest bets to be made in the UK are in some of those areas more than others. And I think that there's a good opportunity to sort of be strategic and say there are going to be things that you can have a minimum viable product in. And there are going to be ones that this isn't really a meaningful intervention. So for example, ASML make the lithography machines that make chips. One lithography machine costs $500 million. There's only one company in the world that can make these. There is no point having a minimum viable product of lithography machine maker on the side. This is not a bet that can be made. Even the Chinese haven't so far managed this. On the other hand, you can have a minimal viable product of secure data centers located onshore. So something like the air growth zones and the air research resource and then bits of sovereign compute for the UK makes sense as a minimum viable play that you can build with. And then you can, as the government's quite helpfully said, you can use that to then reward innovative applications or innovative chip companies and so on. And that fits together, that makes sense. And then you can bet bigger then on the areas of high potential. And I think that fundamentally the two areas that are most high potential for the UK are chip, not the actual fab, but like Fractal, the NVIDIA business model essentially, that you organize the value chain, but you do not do the fabbing yourself, what we call fabless manufacturing. And then alongside application companies. And I think that really gets the best out of the UK's sort of innovation and engineering talent and also our business environment without requiring huge amounts of our natural resources to be pivoted towards one thing.
I think that makes sense. And moving forward, I'll add an extra question to it that I didn't pose to you, Ed, of given what Ed said, what does success look like in 10 years for us as we're competing moving forward?
Yeah, I think that's a key question. What would be really useful, not just for the UK, but internationally, to have an international standard that governs and regulates the development of AGI in all its components, compute being one of them. So because working in partnership, I think, is quite key, which is the point alluded to earlier. When you have academics, innovators with businesses and investors working together with regulators and policy makers on shaping an international standard which would control the development of the AGI in all its components, architecture, structure, tools deployed, etc., that will see the acceleration and the development of AGI in all its components at universal level. What could also be quite significant in terms of contributing to that process, to that journey, is to have maybe at national level a high-profile think tank composed of experts from the academic world, from industry, but also from the policy making, the government, in order to exchange views and shape the direction of travel for the development and acceleration of AGI compute and all the other components of AGI.
Did not think we'd talk about think tank creation in this panel. I'm going to be really honest about that. Rahul, would you like to add to this conversation of what success looks like and what we'd actually need to credibly lead?
Yeah, I think the bigger question is who should we work with on the geopolitical stage for AGI? Obviously, the US for the next couple of years is going down a certain route, and we need to be acutely aware of what their internal policies are when it comes to AI, which is US first. So we should try and see how we can integrate well with the US today, given their rhetoric. But also at the same time, we can't ignore the fact that we've got kind of the EU with quite heavy AI talent as well and semiconductor talent as well in the EU that we should also be working with. At the same time, we have this giant competition coming from China, developing open source language models to try and directly compete with US companies, as well as EU companies and UK companies. So given that that's going on, there needs to be this kind of broader awareness that we do need to start working on these open source models, because if we don't, the likelihood is that if a 1 trillion parameter model gets made available tomorrow by one of the big Chinese players, the adoption across the UK, EU, and US, no matter what anyone in any DoD and MOD says, will be quite high. Most people today that we talk to who are running their own local LLM models are using one of the Qwen models, one of the DeepSeek models locally, because they're just easy to use and integrate. So if we really do want to compete as the UK, we need to collaborate with those that we're friendly with, but also be acutely aware of no matter what we do, we've got this competition coming along where the development of models is going to accelerate massively, especially in the robotics field, and they're going to be open sourced. So we need to compete on that stage, not just on the commercial closed model source stage. The thing when it comes to 10 years from now, I think it's so challenging to do 10-year projections, right? And reason being one, we don't know what technology is really going to win out in the next 10 years. Yes, we've got semiconductors today. Who knows what it'll be in 10 years' time? Will quantum hold a promise? We don't really know. Yeah. But at the same time, we will find different innovations going on in the actual fundamental algorithms that we're using, and whether or not there'll be something that's more efficient that can be scaled down and trained in a much smaller footprint, that could potentially come around. And we saw this with reinforcement learning. You know, the amount of work that went into RL-based verification methods with verifiable rewards, that completely changed the way that we start training large language models. If that happens again in the next year, 2 years, we might then have to shift to a completely different paradigm. When I was talking about energy-based models earlier today, energy-based models require also different hardware. You need completely different hardware than to what we have today, even for inference, because you're not only doing forward passes, you're back propagating whilst you're running these models. So we're already starting to see things changing at a 6-month to a year timeline. In 10 years, it's going to be predominantly robotics-driven, edge-driven, as well as kind of some meta large-scale compute infrastructure as well as part of that.
No, I think that makes sense, and there is definitely a few sci-fi references that have not aged well in 10 years that, if we were to predict here today, end up probably like one of those.
Could I be cheeky and answer the question you put to the others?
Yeah, of course. Go for it.
At the risk of sounding cynical, I think that you're bang on that we need to be working with partners, but I think also we need to be a credible player. And so we need to pick those. I think what success looks like for the UK, is finding those areas where we can win and then being so good at it that no one else can do something without our best stuff. And this is the position that Taiwan find themselves in. It's the position that the Netherlands find themselves in with ASML. It's the position that the Americans and the Chinese are fighting for with the models. I think that we can do this in chips and applications. And I think that really success looks like someone else's AI stack is not top tier unless it has UK stuff in it.
Okay. So versus US first, figuring out the UK angle, if you will.
Well, right now it's actually, what Rahul's saying is we have to work with them. But what we need is a situation where they also have to work with us.
Okay. I understand that a bit better. I was going to do final remarks, but I actually weirdly think that last question did quite well on final remarks. Is there any final statements you guys would like to make before we pivot to Q&A?
I'm fine.
Awesome.
No, nothing.
Okay. In that sort of regard, Q&A. If you could just raise your hand, we've got a team member in the back with a microphone. And given there are not that many questions, we can go individually. There's a guy in the blue shirt over here. Ella, there are 2 colleagues. I'm looking at the wrong one. And then you will be next.
Hello, thank you. It feels like we've been talking a lot about the physical infrastructure and resources, but we can assume that we have quite enough resources and a lot of compute power already now in the world. If we just assume that we combine it all together, we will still not get AGI automatically, right? And we know that there is a gap, still the gap between the LLM and AGI. So do we think that the gap is caused by that compute or memory power, or is there something more or something else? And what can be done or shall be done on the academia or corporate or national level to address that gap? Thanks.
Abdul, I think your remarks talked on this a
Yeah.
bit. Would you like to expand on the
Sure.
question?
Yeah. I mean, compute is one of the bottlenecks, but it's not the only one. We did touch on algorithmic prematurity as part of this journey to reach the final goal of deploying an AGI model with all its compute capabilities. We need to go through algorithmic developments first, which at the moment is lacking. And this is not just for the UK, I'm talking universally here. So I think if you talk about combining the existing computer platforms worldwide, will that be sufficient to generate the first AGI model which can mimic, if not surpass, human intelligence? My guess is that no, because the element of diversity is very important and the scalability. If you merge all the computing platforms together worldwide, will that give you a scalable enough platform that could scale up and down based on the task at hand or the type and nature of data sets that it has to deal with? The answer is no. We need to combine not just platforms but technologies, thinking about edge compute, about photonic-based infrastructures, about neuromorphic paradigms combined together and scale them up and down based on the task at hand and the type of data that is going to be dealt with.
Ed or Rahul, would you like to add to the answer?
I totally agree with what Abdul was saying, and also his point earlier about reinforcement learning, that the models that we're deploying now learn as they do, which means that the compute you deploy is much more effective. And I think we've seen this visibly in the sort of the reasoning model paradigm, but this is also, it's really radically changing how the models are developed, not just deployed. And that's really, really key. But also, the more reasoning you do, the more compute you need, the more effective compute you need. It seems like we have a huge amount of compute in the world, but the chips we will have in 2 years will perform so many more operations than the ones we have now, that there is, in fact, there's a ski ramp to a ski ramp for how much computing power you can have effectively, because we will continue to make that compute much better. And so it looks like you've got a lot now, but just wait.
Yeah, I would just say, I think the architectures will need to change. I don't think you can keep just throwing parameters at a model and thinking it's going to work. I think at some point there needs to be recognition that we need to move to something better. And Meta have already started talking about this. Amazon have also, with their AI research lab, been talking about this, and the shift away from let's just throw another trillion parameters at a model and see if it works. But I think it is that learning journey, and that's where the tie back to academia is really required. The compute that we have today, yes, probably won't be the compute that we're going to need in the next 3 to 5 years, but we do need to research the software and the algorithms to understand what that compute's going to look like and what we're going to need.
Yeah.
Amazing. Okay, I'm going to move on to the next question.
Thanks. Thank you to the panel. Yeah, really interesting conversation. Is this working? Should I? Something.
It is,
There we go. Thank you. Yeah, thank you very much. Yeah, a lot of high-profile people are, calling out very publicly that they're very worried about the development of AGI and what it might do for society. Yoshua Bengio, many others, I think, recently signed a letter sort of calling for research to stop on AGI. So to turn the question on the head, can the UK stop the development of AGI, or should it be developed by the state as a national security capability? Thank you.
Oh gosh, okay. I'm going to leave it to you guys on who goes first on that one.
I think it has to be done at national, if not global, level, because the final goal is a capability which is beneficial to the human race. It's not just one particular section of beneficiaries, because everyone will benefit from the AGI model in the sense that it will enable us to understand, learn, analyze, make decisions, etc., and apply this knowledge extracted from one domain to multiple other domains as well in all walks of life. Hence, it is very important that it's an agglomeration of efforts, not just from the experts, but also from governments all over the world. That's my take on it.
So my view on this is that models should be open sourced, and the reason for that is because to that exact problem, if you can verify it yourself and actually check what the weights are, what the parameters are, and do testing on it, you can verify what the model's actually doing. If you don't have that, you're trusting a large organization with their ability to test this. And we've seen with the work even that NIST has done on trustworthy AI and their kind of benchmark that they released, it won't take long for someone to just make it look like an AGI system is really trustworthy, even though it may not necessarily be. So when it comes to from a national security perspective, we can do whatever we want in the UK, but we're also competing against the rest of the world when it comes to these systems. And if China suddenly says, no, we're not going to do that, we're just going to develop our own AGI systems, we're going to be outcompeted by them. So realistically, no matter what we try and do, we will always be in competition with someone else out there, and we do need to do it ourselves and own that ourselves as well.
Before I let you jump in, Ed, there's a man in the middle who will do our next question. If he wants to raise his hand, Ed, you...
Sure. So I think this is actually an area alongside novel chips where I actually think the UK is possibly ahead of everybody else in the sense that we have the AI Security Institute, which has done, admittedly closed, and I think there's a reasonable debate to be had on whether or not it needs to be closed, but they've worked with companies like Anthropic and OpenAI to do internal safety testing and investigate the models, and I think the UK's it's been a really, really good bipartisan effort between the last two governments to build that capability in the government and find the right people and pay them the amount they need to be paid and sort out everything necessary to have that capability. And I think that's been a really, really good effort, which has given the UK a really good piece of sovereign capability that we have people who work for our government who are looking at the inside of a frontier model with not just one of the major companies, but multiple. And I think that's a really, really it's a really, really impressive thing to have done, and I think it's a really important part of the puzzle of AI governance as we move forward.
Okay, not to put pressure on you with the microphone, but I think this is going to be our last question.
Okay. So the demand for water in the UK, is going to outstrip supply by about 5 billion litres per day in the next 5 years. And the demand for electricity is going to outstrip supply probably the next 2 years. How do we convince the UK public that we should be investing our natural resources in this and that they should stop watering their front gardens?
I mean, the AGI compute infrastructure that I envisage is going to address exactly this, is to make the speed of execution faster for a lower power consumption. By making the infrastructure scalable, depending on the nature and the type and the requirements of the task at hand, as well as the volumes of data it has to deal with, you're making the data processing more efficient, cost-effective, and faster. So power consumption is one of the key factors that AGI will have to address, and that's absolutely right.
I'd also like to add that in certain data centers, if you're running your workload in an immersion-style system, you may not necessarily need the water supply. So the innovation happening in immersion-style techniques, whether that be kind of full immersion of the system all the way through to kind of pump-based immersion techniques as well, that is lowering what that requirement is for water consumption, number one. Number two, I think making a clear case by practical examples for the public will be the only thing that really convinces people. Because no matter what, if you can't see it and you can't actually use it, you're not going to care. You're going to say, why are you using all these resources?
Yeah, I totally agree with that. Especially like, the second, like power plants are here, but no one disputes the need for power plants because we understand what electricity is for. I think that the first point will definitely be to bring that in, and also, to make the case not only for why this needs to happen, but also why it needs to happen in the UK in particular cases. So, for example, I think there'll be all sorts of ones where that's relatively easy selling, could be part of the story, like NHS patient data, for example. Like having a data center in the UK may be ugly, but it will also prevent you from offshoring your NHS patient data. We'll see the reason for that. And those sorts of examples will be key. And then I think the second part of it is also the prosperity story. That right now, a lot of the time there's this implicit narrative and sometimes an explicit narrative that the value in these technologies is captured in California only. And the antidote to this is having UK companies which capture the value here. And if everybody is aware of the fact that not only is this useful at the consumer level, but also they're aware that it kind of comes back to what you were saying ages ago about the problem of engineers going into the city. If people know that you can go out there and you can get a job in tech and AI in the UK, and that could be a bricks and mortar job putting the cabinets together, or it can be a really cerebral job like working on the models, it can be anything in between. There's a whole world out there of people getting more behind this because they see it as it's a job growth area, it's something which makes the UK more prosperous, and people win from that, not just because they find the product useful, but also they can be part of the value chain. I think we haven't seen enough of that story yet.
I think that ends us on quite a positive note for economic growth, so let's leave it there. Thank you guys so much for joining us on this conversation. Thank you guys for the questions, which definitely deviated from where we had gone with ours, so it's really nice we got a full spread of what we could have talked about during this, and thank you guys for handling them.